How am I supposed to analyze all this data efficiently? Hi Alya, I just finished sorting my data. Why is analyzing data so hard?
What do you mean hard? Let me show you how coding can make data analyzing easier. Answer my call. Hey Budi, wrestling with data, huh?
Yep, I have so many studies to analyze, and the manual work is just unbearable.
I know the feeling. That's where coding comes in. It helps you manage, analyze, and visualize complex data quickly. In health sciences, coding is vital for transforming raw data into meaningful findings. It involves assigning labels to segments of data to capture key themes or concepts, which can be predetermined or derived from the data itself. This process is essential, especially for complex analysis like network meta-analysis.
So, coding makes it easier to discover patterns and insights in my data.
Exactly. It aids in organizing data, making it much simpler to analyze and visualize, especially in qualitative research where understanding nuanced human experiences is crucial. We can categorize data through two main types of coding. First, deductive coding. It utilizes existing theories to categorize data, giving a structured approach to analysis. Second, inductive coding. It emerged from the data itself, allowing for a more exploratory analysis that can lead to new theories. Tools like SPSS enhance this process by providing a user-friendly interface for quantitative data analysis. But coding in programming languages like R and Python is becoming increasingly important for conducting complex analysis, including network meta-analysis.
That's amazing! So, now I can see how different treatments stack up against each other.
Exactly, and it's superficial too. Check out this forest plot summarizing the outcomes. Now that you see the magic of network meta-analysis, let's talk about the key coding languages used in health science research and their applications. Here are some that are widely used. RStudio is widely used for conducting meta-analysis due to its statistical packages. It allows researchers to perform complex statistical modeling and visualize results effectively. Key packages like Meta and Metaphor facilitate the synthesis of data from multiple studies, providing insights into treatment effects and heterogeneity. SPSS is a powerful tool for analyzing primary data collected from health studies. It offers a user-friendly interface for performing descriptive statistics, t-tests, ANOVA, and regression analysis. Researchers can easily interpret results through its graphical outputs, making it suitable for non-programmers. Jupyter Notebook supports interactive computing, allowing researchers to document and share their works like in silico. It integrates Python libraries like NumPy and SciPy for numerical analysis and data visualization. The platform's flexibility enables execution of complex algorithms and simulations in a collaborative environment. Autodoc is a specialized software suite used for molecular docking, especially popular in drug discovery research. It enables researchers to predict the binding modes and affinities of small molecules to receptor structures, which is critical in evaluating potential drug candidates. Autodoc, along with Autodoc Tools and Autodoc Fina, allows users to set up, run, and analyze docking simulations. Its scripting capabilities also allow for automation of complex workflows, providing a powerful tool for molecular modeling and virtual screening. Python is increasingly favored for its versatility in data analytics and machine learning applications. Its extensive libraries, such as Pandas and Matplotlib, facilitate data manipulation and visualization. Python's low learning curve and community support make it an ideal choice for researchers in health sciences.
Wow, it sounds like each language has its own strengths.
Exactly. Depending on your research needs, you can choose the one that fits best. Now you see the magic. Here's why learning coding languages is a game changer for research. First, efficiency. By automating repetitive tasks, coding frees us from time-consuming data cleaning and enhance our productivity. Second, accuracy. Say goodbye to copy-paste errors. Third, reproducibility. Share your code with others so they can replicate your analysis. Fourth, career boost. Knowing coding gives you a competitive edge in academic and industry research.
Honestly, this already feels like a superpower. Oh, Alya, is there anything that really needs to be paid attention when doing the coding process?
Sure, Budi. In the coding process, you need to pay attention to the following things. First, case sensitivity. Many programming languages are case sensitive, meaning that variable and variable are treated as different identifiers. These can lead to errors if not managed properly. Second, data types. Understanding the data types you're working with, as example, integers, strings, arrays, is crucial, as each type has its own properties and methods. Third, code quality. Writing clean, well-documented code is essential for maintainability and collaboration. Following best practices can significantly improve code quality. Fourth, error handling. Implementing robust error handling helps manage unexpected inputs and improves user experience. Fifth, testing and debugging. Regular testing and debugging are vital to ensure that code behaves as expected and to identify issues early in the development process. You really have to pay attention to this so that your coding process runs smoothly.
Thanks, Alya. I can already tell this is going to make my research way easier.
Anytime, just remember, coding isn't just about crunching numbers. It's about turning data into discoveries.